function is a variable x and range is a variable y, and determine range item the function I examine graphic equation and domains one course and range two course and example f x 1 sub x más 2 and x valores de x negative 2 negative 1 0 1 2 and negative 2 and result de function valores de x menos 2 no exist, menos 1 1 0 infinite 1 3 y 2 2.5. El domain valores de x, entonces el domain son los números reales negative 2. And rank valor de la función f de x. El rank es negative infinito and menos 2 and menos 1 and infinite. Entonces los valores de domain y rank son los reals and menos 2 y el rank es menos infinity menos 2 and intersect.
minus 2, and 4, and the other bracket. And now we are going to calculate the range. So g is equal to this function. So it's the square root of 8 plus 2 to x minus x squared minus 2. This is equal to g plus 2 equal to the root of 8 plus 2x minus x squared. And now we have to put this here. So g plus 2 is greater than or equal 0, and parenthesis g plus 2 parenthesis squared is equal to parenthesis the root of 8 plus 2x minus x squared parenthesis, and we have to elevate to square. And this is equal to g greater than or equal times 2. And now we are going to put parenthesis g plus 2 parenthesis square is equal to 8 plus 2x minus x squared is equal to minus we have to complete the binomial square to clean x, so we have to minus parenthesis x squared minus 2x. Here we are going to plus 1 and minus 1. This is because, like I said, we have to complete the binomial square to clean it. So parenthesis plus 8. And this is going to be g plus 2 parenthesis square equal minus x minus 1 parenthesis square plus 1 plus 8. This is this. It's equal to minus here we have that this parenthesis x minus 1 square. So we were using this here, but change the sign. And this is equal to minus parenthesis x minus 1 parenthesis square plus 9. We solved it, and this is the result. And now we have to put parenthesis x minus 1 parenthesis square. This is square because any square quality is greater or equal to 0 for all x in the real numbers. So this is equal, well, for that reason, this is equal to 9 minus parenthesis g plus 2 parenthesis square greater or equal to 0.
Step 1. Dominion. First, we lock the expression inside. The square root must be greater than or equal to 0. So we write x plus 5 is greater than or square to 0. So with this, we get x is greater than or equal to -5. Therefore, the denomination is from negative to infinity. And step 2 is now we're gonna arrange the square root is always greater than equal to infinity. And step 2 is now we're gonna arrange the square root is always greater than equal to 0. The smallest values happen when x is equal to -5. Substitute of -5 square root of 0 plus 3, which is 3 as x increases, the square root increases, and f of x goes to infinity. So the range is from 3 to infinity. Step 3, we're gonna do the table of the evolution, the values. To graph the function, we make a table of values. When x is negative 5, f of x is equal to 3. When x is equal to negative 4, f of x is equal to 4. When x is equal to negative 1, f of x is equal to 5. When x equals 0, f of x is equal to the square root of the 5 of 5 plus 3, which is approximately 5.24. And when x is equal to 4, f of
To solve this exercise, first we need to solve if is a definite equation which tells us that the numerator can be 0 but the denominator cannot. The second step is factor. What we are going to do is look for numbers that when subtract give us 1 and when multiply give us 20. The second step is to factor. What we are going to do is look for numbers that when subject give us 1 and when multiply give is 20. This will be 5 and 4. This x is not equal to 0. X plus 5 is not equal to 0. X plus 5 is not equal to 0 and x 4 is not equal to 0. X minus 4 is not equal to 0 and x minus 4 is not equal to 0. X must be different from minus 0. X must be different from negative 5. So in the graph we can take a real number except negative 5 and 4. This means method domain will be negative infinite, 5 u negative 5, 4 u 4, infinite. This tells us that we can take from negative infinity to 5, from negative 5 to 4, and from 5 to infinity.